Hello guys. So in today's daily dose episode, we are going to discuss a wonderful concept. And guys, this is going to be very important for the interviews. Like now, bark season is starting. So in the bark, that kind of interview question have been asked before as well. So guys, if you remember in one of the daily dose episode, I already talked about this concept, eigenvalue principal stresses. Don't worry. Today I am not going for the repetition of that. Today I am going to explain that from interview point of view. If you remember, I told you like whenever we write this stress tensor sigma xx, tau xy, tau yx and sigma yy. This is said to be Cauchy stress tensor. And guys, you already know if we want to find out the principal stresses, the first method is to apply the formula known as analytical method. Sigma xx plus sigma yy by 2 plus minus square root of sigma xx minus sigma yy by 2 ka square plus tau xy ka square. And everybody know the second method is the Mohr circle. These are the things which are given in books and everywhere. The third method to find out that is the eigen values. So eigen vectors will give you principal planes and eigen values will give you principal stresses. So you may be saying, sir, what is new in this that you have already told us? Yes, I told you. And at that time, many students asked, sir, what is the logic behind that? Why that is? Actually, the reason was students are not aware of the real meaning of eigenvalues and vector. And I have seen from the students' experiences that this explanation are many times asked in BARC, ISRO, DRDO, that kind of interviews. So that is why I am coming today to explain that, and before that we need to understand the meaning of eigenvector. Let us say we are having a matrix A that is 1, 2, 2, 4, and let us say we are having another matrix X that is 1, 1. If we are going to multiply them and we are going to find out AX, we will be getting 3, 6. I feel everybody is aware of matrix multiplication. So you can see previously when we were having a point 1, 1, now that point have been shifted to 3, 6. 1, 1 have shifted to 3, 6 when it is multiplied A into X. So my dear, initially if I show this as a vector like this and show this as a vector like this, you can see there is a scaling happened. Why scaling? Because the magnitude have been increased and also rotation happened. So this operation is scaling plus rotation. But my dear, if I would be having another matrix X dash which is 1, 2, if now I will multiply AX dash, you will be getting this time 5, 10. And my dear, for this, if I want to plot it, initially point is 1, 2 and then the point is 5, 10. If you see carefully, it is coming on the same line. So what do you mean by that? It means here only scaling happen but no rotation. Scaling without rotation. And for this case, you can also take 5 common and you can write 1, 2 again, which can be written as 5 and once again the vector X dash, which is also equals to AX dash. So my dear, if you remember the same thing you do at the time of eigenvalues, when you write AX is equals to lambda x. So my dear, what it means? It means that eigenvectors are those kind of vectors which produce only scaling without rotation. Only scaling without rotation. So here we try to understand the meaning of eigenvectors. Okay. So now my dear, we will see how these eigenvectors are showing us the principal planes. If I will be having a shaft and let us say in this shaft I am going to apply some twisting moment like this. So because of this twisting moment, if I want to see the state of stress of a point, then the state of stress of this point will be pure shear like this. This will be pure shear like this. Okay. And if this is pure shear like this, my dear, so if that is the case, if I consider any you can say on this point, if you see these two planes, on these two planes we are having the state of pure shear. And if you will be making the Mohr circle, from that definitely you can find out the principal stresses. If this is the Mohr circle, you will get this is sigma 1, this is sigma 2, and you will get to know here sigma 1 is coming out to be plus tau, sigma 2 is coming out to be minus tau, and also you get to know that they will be the diagonal planes. These are going to be the principal plane. So in the same body, I want to say that the planes which are shown at this and this, they are 45 degree because they are diagonal planes. So my dear, if you are talking about these two planes, here it was like x and y. If I take here x dash and y dash, because you know they are the diagonal planes, they are the planes which are having zero shear because they are nothing but the principal plane. So if you are talking about these two planes under the action of twisting moment, they can increase or decrease in size, but there will be no rotation happens. Means if you are having one principal stress to be plus tau, other principal stress to be minus tau. So if I am showing this, here I am saying this is going to be tau, here I am showing this is going to be minus tau. So what do you mean by that? That there may be expansion in this direction, contraction in this direction. So my dear, in these two planes I am showing them as x dash and y dash. Here scaling is happening, but my dear, rotation is not happening because shear is zero on that plane. So it is very much similar to the concept of eigenvector, where scaling was there, rotation was not there. So that is why my dear, eigenvectors denote the principal planes and eigenvalues denotes the principal stresses. Guys, this is the wonderful explanation of that concept which I already have taken in one of the daily dose. And if that kind of thing is asked in interviews, if you will explain like that, you are going to get 100% marks. And in BARC, ISRO, that kind of things are coming. That's why I have taken this in this today's daily dose. So stay tuned guys on this channel for such wonderful videos, daily dose, which are coming on the regular basis to enhance your knowledge, which will help you in interviews as well. So goodbye guys for this session.